Have you ever wondered why a guitar sounds different from a piano even when playing the same note? Welcome to the fascinating world of physics where even music dances to its tune. So let's dive into this melodious ocean and understand why your favorite instruments sound the way they do. Music, in its essence, is a series of sound waves. These waves are created when something vibrates, like a guitar string or a drum skin. The vibrations move the air around it, creating waves of pressure that our brains interpret as sound. Pretty neat, huh? Now, not all sound waves are created equal. Depending on how and where these vibrations occur, different instruments produce different types of sound waves. This leads to the unique musical tones we know and love. Consider a flute and a violin. Even if they play the same note, they sound distinct. That's because the flute, a wind instrument, makes sound by vibrating a column of air, while the violin, a string instrument, vibrates its strings. These different methods of creating vibrations result in different sound waves, hence different musical tones. But what about the role of vibration in creating sound and music? Well, imagine plucking a guitar string. The string vibrates back and forth, moving the air particles around it. These particles then bump into the ones next to them, causing them to vibrate too. This chain reaction continues, creating a wave of vibrations or sound waves that travel through the air. Once they reach our ears, we perceive them as the beautiful melodies or rocking riffs that make us tap our feet. So, the next time you listen to your favorite tune, remember that it's not just an artist's skill at play. It's also a symphony of physics, a concert of waves and vibrations, creating the music that moves us. Understanding the physics behind music opens up a whole new world of appreciation for the art. But how does the shape of an instrument affect its sound? Stay tuned to find out. Why does a violin string vibrate differently than a guitar string when you pluck it? It's all about harmonics and overtones, the unsung heroes of the musical world. These are the elements that give each musical instrument its unique voice. So let's take a deep dive into these fascinating concepts. When you pluck a string on a guitar or a violin, it doesn't just vibrate as a whole. It also vibrates in smaller sections, each producing a different pitch. These are harmonics, and they're like the hidden chorus in the background of the main note. Now imagine you're plucking a guitar string. The whole string vibrates and gives us the fundamental tone, the lowest and loudest note. But at the same time, the string is also vibrating in halves, thirds, quarters, and so on. These vibrations produce higher pitches that are multiples of the fundamental tone. These are our harmonics. Overtones, on the other hand, are all the other tones that resonate above the fundamental tone. They include the harmonics and are crucial in defining the timbre or color of the sound. For instance, think about a grand piano and a tiny ukulele. They can both play the same note, let's say a middle C, but they don't sound the same, do they? That's because the overtones produced by the piano are different from those produced by the ukulele. These overtones are shaped by factors like the size, shape, and material of the instrument, and they give each instrument its unique voice. So when you listen to a symphony orchestra, you're not just hearing a bunch of different notes. You're hearing a complex interplay of fundamental tones, harmonics, and overtones, each contributing to the rich tapestry of sound. So, the next time you listen to your favorite song, try to identify the harmonics and overtones. But wait, how do these concepts apply to wind instruments? Keep watching to discover more. Did you know that the material and shape of a musical instrument can drastically change its sound? Fascinating, isn't it? Let's dive right into it. When we think about musical instruments, we often focus solely on the sound they produce. But what we might not realize is that the shape and material of these instruments play a significant role in creating that unique sound. Take a violin, for instance. Its curved wooden body and the long, slender neck work in tandem to amplify and shape the vibrations from the strings. The type of wood used, whether it's spruce or maple, can also impact the instrument's resonance. Spruce is light yet strong, perfect for the top plate of a violin where most of the vibrations occur. Maple, on the other hand, is denser, ideal for the back and sides of the violin to reflect sound waves effectively. Similarly, brass instruments like trumpets and trombones have a unique flair in their design. This bell shape allows for a wider range of sound frequencies to be amplified, resulting in the brassy sound we associate with these instruments. Even the material of the strings can change the sound of an instrument. A guitar string made of nylon will produce a different sound compared to one made of steel. Nylon strings tend to give a mellow, warm tone, while steel strings provide a brighter, louder sound. And let's not forget percussion instruments. The material of the drum head, be it synthetic or animal skin, and the shape of the drum itself can drastically alter the sound. A larger drum will produce lower pitches, while a smaller drum will produce higher ones. So, you see, the physics of music is not just about sound waves and vibrations. It's a fascinating interplay between these elements and the materials and shapes of the instruments. Now, here's a question for you. Can you think of a musical instrument where the musician's body itself changes the sound? Intriguing, isn't it? Drop your answers in the comments below. So, we've taken a journey through the fascinating world of the physics of musical instruments. We've discovered that sound waves, those invisible forces that tickle our eardrums, are the fundamental building blocks of music. They vibrate at different frequencies, creating the diverse pitches we hear. We've also delved into the realm of harmonics and overtones, uncovering the secret layers of sound that give richness and depth to a single note. These are the hidden harmonies that make music such a captivating experience. And let's not forget the role of the instruments themselves. The shape and material of a musical instrument are not just about aesthetics, they are integral to the sounds they produce. Each instrument is a finely tuned machine, designed to create a unique voice in the symphony of sound. Next time you listen to music, think about the physics behind those beautiful sounds. And remember, music isn't just an art, it's also a science.